NASA Ames Research Center and at the SETI Institute, he investigates a wide range of chemical reactions that are either needed for life to begin, that may affect whether life can exist, or that might be used by scientists to recognize life elsewhere. For example, he's looking at the reactions of nitrogen in the atmosphere of ancient Mars. He's interested in where it went and whether it could have provided nitrogen for the start of life on Mars. Another example of a process he's interested in looking at are reactions that might occur in cell-like structures for the origins of life. Next to him is Scott Hubbard. Scott is the former director of NASA's Ames Research Center. He was NASA's first Mars czar, and he's been a key contributor to space science for more than 35 years. He is also the author of Exploring Mars, Chronicles from a Decade of Discovery, which I believe is available in the bookstore in the exhibit room. Is that right? Yep.
Right, yes.
And this book describes his work in successfully restructuring the Mars program in the wake of 2 failures in 1999. So next to him, we have Richard Quinn. He is also a chemist at the NASA Ames Research Center. He focuses on understanding whether the surface of Mars is really sterile. Could there be still undiscovered traces of life littering this hostile landscape? As the Viking landers found 3 decades ago, there's an abundance of complex photochemically driven oxidative processes on Mars. And Richard thinks that the key to understanding Martian carbon chemistry is to unravel the dominant reaction mechanisms and kinetics of soil reactivity and organic compound decomposition on the surface. So he can tell you much more about this. And he has a fan club, obviously. And finally, our 4th member is Robert Picardo. He's a graduate of Yale University. He's been a well-known actor on stage, screen, and television for over 25 years. Mr. Picardo is recognized around the globe for his popular role as the holographic doctor on Star Trek Voyager. He also starred as Commander Woolsey on Stargate Atlantis, making him the only actor to play regular roles in both of television's most enduring science fiction franchises. He's also well known for his roles on China Beach and The Wonder Years, for which he received an Emmy nomination, not to mention countless guest star appearances on other shows. And he's also appeared in many feature films and on Broadway. So we won't ask him to tap dance or sing, but it's really a pleasure to have Robert Picardo on our panel today. Maybe the audience members could ask him. So let me begin with David Summers, who's going to give you a couple of introductory remarks about the race to find alien life.
So to begin with, how would you look for life? Well, I think it could be characterized by both how close you need to be and how direct your evidence is. The most direct evidence, of course, is the sea life. As Carl Sagan was known to say, we've been to Mars, and we know there aren't silicon giraffes walking around the surface, and if there were, we would have detected them. And in fact, as I look down this table, I feel that I've detected life. And you'll notice I will avoid the obvious and cheap joke about intelligent life. So
we'll save that for the end.
Yeah. Anyone who does make it will be too mean, I guess. So that's the most direct and obvious way. But the problem is you have to go there, and the life has to be extant. In other words, it has to be there now, and you can see it. And the opportunities for that are probably becoming vanishingly rare, because the places we can go to, we've kind of been to increasingly, and so the odds we're going to see it are low. Possible exception is Europa, which has this big ocean hiding under this ice pack, which you might be able to get down to, and you might, though it's unlikely, you actually see a European fish swim by. Maybe. So then the question is, what do you do if you can't do that? And it comes down to more indirect. One way of being indirect is to go to a spot where life might be and see signs that it left behind. Dinosaur bones would be an obvious one, though if you're talking planetary timescales, you're probably more talking about just the chemicals they leave behind. That can be done by getting to, say, the surface of the planet, and it's more direct. It's less direct than seeing it, but it's more direct in other ways. So it's kind of a intermediate. You know, you'd like to be able to get there and get hands-on and see it if you can. But that's pretty much only going to occur in the solar system, because that's really the only place we can go to. Then the third way is what they call remote sensing. You sort of hover over the planet, or you hover a long distance away, and you look for things which say, aha, life probably made those. If Mars was covered with vegetation, we might have been able from spacecraft see the green spectrum of chlorophyll and say, okay, there's life there. And on these extrasolar planets now that are becoming numerous and exciting for the possibility of life, that's in fact what we're going to have to do. We're going to have to actually get spectrum from the atmospheres, or if we're lucky, the surfaces, and try to infer whether life was there. Which brings up the final comment I want to make. Once you see evidence, there's going to be a controversy over what is life. have you really found it? Some of you may remember the controversy over the Mars meteorite and the possibility for life. And one question that brought up, for instance, suppose you see little spheres in the rock that are the right size to be cells. Have you proven there's life there? Well, the problem is there's inorganic structures that could be that size. You find amino acids. Well, we find amino acids from meteorites that people don't think are from life. So it's probably going to be a synthesis of various forms of evidence to find life.
Great. So, thank you very much. I'm delighted to be here this afternoon as a recovering bureaucrat. Now at Stanford University. I'm going to take the opportunity to talk about the missions. And 3 different categories of missions that have all been harnessed to help understand habitability in our solar system and maybe in other solar systems. First one I'm going to talk about is Mars. I had an extraordinary opportunity 12 years ago to restructure the entire last decade worth of Mars missions after 2 of them disappeared, the Mars Polar Lander and the Mars Climate Orbiter. So working with the science community and with the whole NASA infrastructure, we took the program back down to a clean sheet of paper and rebuilt it along scientific lines. And what we said we needed to do was to understand Mars as a system, its past and present climate, its geology, and the first among equals of those questions was, could Mars have ever been habitable, and perhaps is there even evidence of life there today? And a way that we approached it 12 years ago was to say, what is the common ingredient for all life as we know it? And the answer was liquid water. So this last decade of Mars missions has been focused around the concept of follow the water. There are many other questions that have been addressed, lots of very deep and complex scientific questions that I'm sure we'll talk about. But that notion of follow the water encompasses a lot of information that you need to gather, both from orbit as well as checking out those orbital remote sensing observations on the ground. So in the case of the last decade of Mars missions, we saw from orbit evidence of things that look like the chemistry associated with water and the geology associated with water. And by going to those types of places with spirit and opportunity, we have been able to, in fact, verify, yes, there are minerals here that are clearly associated with the presence of water for a long period of time. The 2 great rovers, Spirit and Opportunity, for which the warranty was only good for 90 days. Yeah, lots of good engineering. A little bit of help from Mother Nature in terms of dust devils that clean off the solar cells. So those have been fantastically successful, and Opportunity continues today. The Odyssey orbiter, named for Arthur C. Clarke's Mars for 2001: A Space Odyssey, collected evidence of what appeared to be enormous areas where the water ice content in the first 3 feet, the first meter, was up to 80% by volume. That measurement was checked by the Phoenix mission that went to the North Pole of Mars and in fact did find right there under the lander huge blocks of ice, and verified with the onboard chemistry set that we indeed had observed water ice from orbit. So if we have this much water ice frozen into the top of the Mars soil, then the possibility of liquid water underneath becomes greater. So the next step, building on what the Mars Reconnaissance Orbiter has seen, this is our spy satellite around Mars. Its fundamental measurement size is maybe 30 to 50 centimeters, something about the size of let's say, a volleyball. The measurements from that orbiter have allowed us to pick the landing site that will occur on August the 5th at around 10:15 p.m. California time for the Mars Science Laboratory for Curiosity. And it carries an amazing suite of instruments. It's the most sophisticated mobile laboratory we have ever sent to the surface of another world. And if there is methane in the atmosphere, it ought to be able to sniff it. If there are organics in the soil and the rocks, it's got 2 ways to test for those. And I will be glued to my television set. I encourage you to do that as well, because I think that that will be a fantastic mission. Let's next talk about Europa, one of Cynthia's favorite planets, or actually worlds. It's not a planet, it's a world. Very recently, there was released something called the Decadal Survey for Planetary Science. This is a product of the National Academy of Sciences, and represented the work of about 1,700 scientists over a year and a half, and it came to the consensus that for the next decade, the two most important things to do for major missions was, one, go to Mars and prepare to bring samples back, and two, go to Europa and carefully measure that ice-covered world and see if there really is, in fact, an ocean underneath, and take the measurements that may help us determine whether there is, in fact, a habitable world there. I was fortunate enough to just chair a review of 3 mission concepts. I think 2 of them are extremely exciting and, in my view, very affordable. One that would orbit Europa, the other that would make multiple flybys of Europa, and either one of these missions would return a fantastic collection of information somewhere over the next decade or so. Final mission I want to talk about is Kepler. This was the brainchild of a NASA Ames scientist named Bill Barucki. He published the first paper on this in 1984. I started working with him in 1988. The mission finally got launched a few years ago. So this is a testimony to the dedication of the scientists in our community, the fact that they can start with an idea that doesn't bear fruit for 17 or 18 years, I think is just extraordinary. And now Kepler has identified well over 2,000 planetary candidates, a number of which are Earth-sized, and a few of those appear to be in what's called the habitable zone, where liquid water could exist. So just these 3 missions alone, the Mars program, a mission to Europa, the current Kepler mission, are all making extraordinary advances in our understanding of whether there is a habitable environment in our solar system, and maybe there's what Carl Sagan liked to call that pale blue dot, another Earth-like, Earth-sized planet around another star. So I see tremendous things happening now and in the future. Richard.
Thank you very much. To follow on what David introduced you to and Scott, what I'd like to say is that for myself personally, in terms of searching for life or the search in general, I'm always limited by my senses. And I think that Scott gave a great introduction on the different types of missions. And we have an example where we're looking with Kepler. So we're actually looking and observing with our eyes. You can think of SETI, where we're observing by trying to listen. And we have numerous examples of, say, a Martian meteorite where we've touched a piece of Mars. And my interests are primarily looking very, very at small scale things and extending human perception into extended sense of taste and smell, essentially. And we've done this numerous times. And in particular, following up on what Scott is saying, when we went to Mars in the Phoenix mission, we landed on a polygon, a piece of ice. And really what we wanted to do is, as humans, we wanted to taste it and we wanted to smell it. And what we found in the course of doing that, we tasted it. Had a human gone and done that, they would have been poisoned, because the soil has about 1% of perchlorate, which is highly toxic to humans. So my interest, and I'm very excited here because we have, to my right here, we have a person who's involved in essentially public outreach and exciting the community about space exploration and discovering life in other worlds. And to my left, we have a self-described bureaucrat, but who truly has enabled some visionary missions to be accomplished over the course of the last 2 decades for space exploration. And I've been one of the people who have reaped the benefits of that as a scientist. And again, the key to me, the race to search for life, personally I feel it will be found on a small scale, and it will be done convincingly with human perceptions, and that is, what does life taste like? What does it smell like? What does it look like? What does it feel like? And what does it sound like? And when those parameters come together in the right combination, we will be able to say definitively, yes, we've in fact detected life somewhere else in the universe.
That's right.
I have the look of a bureaucrat, but none of the accomplishments. I'd like to start by saying that if you are in the Los Angeles area the first weekend in August, please consider joining Bill Nye and me and a host of others at Planet Fest, sponsored by the Planetary Society. We will have the live data feed from JPL. It'll be a very exciting evening, especially at 10:17 p.m. on Sunday night. I encourage you to come if you can. My presence on this panel is not really fair to my co-panelists. As far as the search for alien life, I, of course, as the emergency medical hologram on the Federation Starship Voyager, I experience a new alien species at least once a week, literally hundreds of them. So this is very old hat to me. Also, if you happen to have seen Prometheus in the last 3 weeks, that pretty much answers all your questions as well. So I frankly don't understand why any of you are here. But having said that, on a weekly basis in Star Trek, we met a new alien who was strangely humanoid-looking in shape and tended to have, you know, just an unusual forehead or ear tips. And eventually, with the reduction in price in computer-generated imagery, we started to get some aliens that weren't bipedal on Voyager, which was very exciting for us. They were, we were freed from having to make them actors in suits, and we could start to imagine really how aliens might look in a world where we weren't simply saving money on our guest stars. Also, of course, I went, because I'm a man of no particular loyalty to any studio, I then moved on to be the director of the Atlantis program, and of course I know all the secrets of the Stargate system throughout the galaxy for instant, you know, wormhole travel. And even though Stargate is set in the present in a secret program that only people who watch the show know about, that all of the aliens I met on Stargate, I must say, were strangely humanoid as well. And embedded in this joke, there is, I guess, a more serious point, and that is that when we meet our first alien, will we even recognize it, or the first evidence, because we are so conditioned by our entertainment, like Star Trek, to look for human-like aliens, both in size and carriage and just everything about them. That because of the limitations of not so much of the imagination of the people that create these science fiction shows, but sort of budgetary restraints. Until, as I said more recently, when we can free our imaginations up a little bit more and have the computers create more interesting and varied aliens. But that is a topic that interests me a great deal. Just what might their scale be? How small so that they're not detectable to a human eye, or how large could they be, depending on various, in their home world, various factors that would limit their size, gravitation and gravitational field strength and all that. Or are we out there basically still looking for the 1 meter tall bipedal humanoid with an oversized head and strange almond-like eyes? But I am very grateful for the opportunities I've had as an actor to spend a day like today with people that are really doing the things that I pretend to do, And it's like going to school and learning and realizing what it is about all this that captures our imagination so much. And if I can be a cheerleader for that kind of encouragement for people's interest in real science just because they have an interest in science fiction and in dreaming, well then I think that, that my work has been a little less silly than it sometimes seems to be.
That's great. So I'd like to thank all of our panelists. And let's open up the floor to questions. We have a microphone right here. Raise your hand.
Oh.
Go ahead.
I was curious about the mechanism. You say it smells. You said it's smelling for methane. What is the mechanism like that does the smelling, and how does the information get to you?
Sure.
Richard, go ahead.
Sure. Well, there are a number of different mechanisms that you can smell something with instrumentation, and a number of them have been used on various planetary missions. For the upcoming mission, MSL, there are two technologies, and the sense of smell is based on the perception of gas molecules, you know, with the nose. And on MSL, the technique is, first it's called a mass spectrometer. And what they're doing is they're basically putting the soil into a little oven, and they're heating it up. And if we smell chocolate chip cookies, then some people may think that something's going on Mars. And then there's also a little more instrument that's a little harder to describe, but it's called a tunable diode laser. And it actually, to me, that actually looks at gas molecules, but it's looking at the same product, and that's what you can you know, put into the gas phase.
Can you speculate, Richard, on what Mars would actually smell like with a human nose?
I personally think it will smell like chlorine. I think that the evidence of perchlorate, which is a highly oxidized chlorine compound, simultaneous with chloride, means that we have to have the species that are in between there. And I think it might smell a little bit like a swimming pool. And I think that chlorine is something we should expect in the Mars near-surface atmosphere.
Or I put it another way, I think it probably smells acrid and dusty.
Yeah. Okay, more questions?
This is a question for the whole panel, not just stage right entertainment person. Do you think it's an issue that there's a discrepancy between the public's perception of what we should be doing to look for life versus the reality of it? Now, obviously, stage right, director, actor, meet public and producers of such things. They have their own ideas, but you get that side of things. But the rest of you also at things like this, media interviews, public events, I'm sure you get questions that take you aback, and I'm wondering, is there a problem because you're doing things that people don't think you should be doing? Why are you looking there?
I think there's always a problem with public perception of what any science is doing and what they're actually doing. In fact, that's why in a lot of situations we try so hard for public outreach so people can know. On the other hand, I don't know that it's all that grim. At a conference not too long ago, some of the people that run some of these museums were talking to us about public outreach and stuff, and they're pointing out some of the messages that have gotten home. For instance, I think it's become generally aware by a lot of the public that when we look for life, with the exception of SETI aside, which was a good point Richard made about that would be a direct detection of alien life by hearing their signals. But SETI aside, we're likely to find microbial life. There's not going to be any, you know, guys with bald heads and big eyes running across Mars. So some of the messages are getting through, but it's always a work in progress.
Yeah, let me comment on the way in which people inside the Beltway see this. When I was doing the Mars reconstruction and building the architecture for the last decade or so, I had to go and work with a group called the Office of Management and Budget. These are These are the people, the real bean counters, the green eye shade folks that you've got to explain to them what you're doing, what it's going to cost, and build the case. I mean, you're trying to sell them your program.
They're not the fun people back in.
Yeah, these aren't, so, you know, these are guys that, you know, take their blue pencil and just strike out whole programs at a single swatch there. So I was explaining to them what this program was going to look like, and I got to the end, which was the Mars Science Lab in the current, that version then. And they had a bunch of questions. I was supposed to be there for 45 minutes. I was there for 3 hours, and they kept grilling me about what it was going to do, why it had to be more sophisticated, why we couldn't just keep reproducing the MERS over and over again. And I kept explaining things about how we need to go further on Mars because it's a very complex and diverse place. And these instruments are meant to uncover whether or not we really did have complex organics and so forth. And so finally, one of the people called an examiner, this is the guy who, usually they're guys, sometimes they're not, would actually bore into the details of your budget. And he asked me with a completely straight face, he said, "Will it discover life before the end of the second administration?" True, absolutely true story. And so I, in the back of my mind, I was going, oh my God, you know. So what I said, well, this is probably going to have a very sophisticated microscope on it, and let's assume that we reach out and we drill a piece of rock and we look at the microscope and we see a little microfossil. And he said, yeah, that would be really cool. And I got the money. So, yes, perception and explaining things is absolutely critical.
And I think I'd just like to add, even within the scientific community, there's a huge debate on what the right approaches are and what they should be doing in terms of the search for life. And again, you know, coming back to the analogy of science fiction, which I'm a great fan, I think that it's useful in that it helps us stretch, you know, what are the possibilities. But the common theme with science fiction, I think, is it's always something that we can recognize. And from the scientific community, the debate and the perception, I think, you know, from the public, is really the question of what should we be looking for, and in the context of will yield the most highest probability of success, because sometimes the best approach actually might not have the best odds. So it's a trade.
I think if Bill Nye were here, he would tell you that $302 million will be cut out of the space science budget this year, and that it's very important for people like those of you in this room to write to your local congressperson and tell them how important you think science is. It isn't a luxury that is unnecessary in difficult financial times. It's a necessity, and so much of so much of our future lies in the discoveries that we're making in space that we cannot afford these budget cuts. So I think that the perception sometimes is that a large part of the general public does not see the importance of space science, and I think that perception is wrong, and that it's our responsibility to let our representatives know that it's wrong.
Excellent, and just a brief plug before we go on with the question. Robert's point is really important, and we've been working on something called the Save Our Science campaign, and you can pick up red postcards in the exhibit area that you can then sign and address and send to your congressional representatives to support more continued funding for planetary exploration. You can also go to our website at SETI.org/SaveOurScience, and you can download sample letters that you can customize, and also links to look up the address of your congressional representative, because actual mail means a lot more than email in this day and age to your representatives. Okay, let's continue on to more questions.
Along those lines, I'll mention that letters you've written yourself actually trump that. Phone calls to your representative are good. And most representatives have a district office, probably not too far from where you live. Go visit, that makes a big difference if you actually show up in person.
My question belongs probably all those panelists here which are present. Do you have any website which is open to the public and inform them how to protect themselves, themselves, their goods and property before the disclosure or any contact through and after, if you have any material, instruction, information? Because there are so many private programs like Virgin Galactic or New Futuristic and activities like that, but there is not a public website to inform how to react, how to protect themselves or others from potential disclosure or activities like that. Thank you so much for any ideas. Thank you.
Who's protecting?
Can you restate that a little bit? You're looking for information about how we could,
like American Red Cross and so many organizations across the world, they do have open public website where you can obtain any kind of free information. And as science institutions or activities, what you do you have any website which is open to the public, inform them how to prepare for potential communication and potential health hazard, how to protect themselves, their goods, their property, before, through, and after potential disclosure. Thank you so much.
So you're asking a question then about if we actually make contact in some way with alien intelligence of some sort, if there's a public website that you guys would recommend that would give advice on what to do, how people could protect themselves. Do we have someone who'd like to respond to that?
Personally, if there's an unexpected visitation, I wouldn't turn to the web. As a non-believer, I'd start praying.
I will add that there's been some concern, especially at SETI, about what the reaction would be to discovering alien life. And I agree with Richard, if they actually land outside the White House, forget everything I said, yes. But, I mean, if SETI finds a signal from outer space, in fact, if you look at the public opinion surveys, actually like a third of the public thinks we've already encountered alien life. And there haven't been riots. So I don't think there's going to be, mass riots or mass hysteria unless they show up, especially if they have spaceships with big weapon-looking like things sticking out. But aside from that, I don't think it'll be a big problem.
That's great. Why don't we go on to another question?
Sorry if this is just like a 101 question, but could you comment on what the basic assumptions are that an extraterrestrial intelligent being would have? Like, would they have a brain? Would they have opposable thumbs? I mean, what could we deduce there might be in the mix?
Who'd like to take that?
I can take it. Well, what SETI decides is, and this is a sort of an in-joke, is that they know how to use a radio. That's pretty much SETI's definition of intelligent life. Beyond that, people talk about it a little bit now and then, but I don't think anyone has any preconceptions, which of course gets back one of the problems. You often hear about people, we look for life as we know it. And every now and then we get questions about, well, how do you look for life? Aren't you looking for life as you don't know it? And the problem is you can't look for something that you don't know what it's supposed to look like. So there has to be some kind of assumption. Probably isn't, a brain organ you can identify as a brain. It's probably going to be behavior for intelligence, whether they've made things that don't look naturally occurring, whether they send you signals that appear to have patterns in them, that sort of thing.
Yeah, and I would take the question back down a number of notches, which is the detection of maybe not even life, but the fingerprints of life. If life existed a long time ago on Mars, then what we have left behind, as I think Richard could elaborate on, are certain compounds, things that are chemicals that are in ratios they shouldn't be, except that they've been acted on by a biological entity. And this is much more likely what we're going to see are either microbes or the leftovers from biological activity. And so what happened 35 years ago with the Viking mission is that which was an extraordinary success on all counts except one, which was the expectations that had been built up, that you would land, scoop up some Mars soil, put it in effect in a petri dish, add chemicals, and voila, you would see the fingerprints of life in the form of organic compounds and so forth. And we didn't see that. The community didn't see that. And many people, including folks like Carl Sagan, thought that we would. And so that really changed the thinking from direct detection of life to looking for a habitable environment, a place where the temperatures and the general surroundings could be hospitable to life. And I'm happy to say that the astrobiology community developed ultimately have been very effective in stretching the boundaries of what we consider to be a habitable environment, because we've discovered, or that community has discovered, so many extreme organisms that we didn't think would be able to live.
And just to follow up really quickly on that, I think from the question was, will they have a brain? Will they have, and really what I think we're hearing here, it's going to be a combination of things, and it'll be very, very difficult to disentangle the number of lines of evidence and put forth a convincing argument that we in fact have found life. But really that is why we're at the table and why a lot of people are here, we hope to accomplish eventually.
So building upon that discussion, just to preface my question, I'm just basically an armchair enthusiast. But I do try to keep track and just see what's out there. But based on kind of my reading, it seems as though the methodology or the current paradigm is for life as, you mentioned, we know it. We're looking for water. We're looking for just about the right temperature, more or less. So what about, what's going on out there in terms of non-traditional forms of life? So maybe non-organic or just different kinds of paradigms. I mean, is there anything going on out there, and what's the scale?
It's life, Jim, but not as we know it.
Right. I think we would turn to our expert.
We actually, I can't believe you're not aware of this. We discovered our first silicon-based life form just 2 years ago. Her name is Siri. And none of you well, all right.
I will reiterate my comment about life as we know it. To some degree, you have to be able to find what you're looking at. Silicon giraffes, that's enough of life as we know it that we think we could detect them. If one were to walk in that door, I think we'd all have a detection. On the other hand, there are crystals of quartz, which are chiral. They form, chiral is a property that life is known to have, but there are inorganic crystals that have it, and they could impart it into organics or even structures that might move or something, and that would be, is that life as you know it? It's hard to say, and it all comes down to the multiple lines of evidence, I think, is what's going to be. And the more life is not as we know it, the more we're going to need multiple lines of evidence, and the more we're going to actually have to know it when we see it, I think.
Yeah, and just to interject, part of the problem is that we don't have a good definition of life. And so, you can say that it's a chemical system capable of undergoing Darwinian evolution, but you're going to be there staring at this chemical system for a really long time before it undergoes Darwinian evolution. So that's not really a very good, you can't really build a spacecraft to do that in any sort of usable lifetime.
Though for the record, there have been a lot of efforts to define life. The problem is they all run into troubles sooner or later.
And just following up on that, just one quick comment. I think that the difficulty with just recognizing a life form that is familiar to us is there are so many hurdles there. I think, and let me preface this with the very, very, very low probability of some, say, non-carbon-based life form, the discovery, it would have to be that life form wants us to know we're alive. They are alive. We can't. It would have to be somehow telling us, and which in some way is what the SETI search is based on.
If we do discover life elsewhere in some way that isn't just like fossils and rocks, but that tells us something about its chemistry, is there any way that that could tell us something about the origin of life on Earth?
As I was saying earlier, one way which we try to infer the origin of life on Earth, one way is to take chemical reactions and look what might have led to life. And there you're ruling out chemical reactions. You need to know what to rule out. The other way is to take life as we know it and look back at all the organisms, what they all have in common, what looked like developed early, try to infer back the other way to life as we know it. Both those things require you to make assumptions about what was important for life and what wasn't. If we found alien life, it would be enormously big for the origin of life. For example, one issue is DNA. It's very hard to see how a molecule that complex got formed on a prebiotic planet. People have proposed things that are like DNA that occurred in intermediate periods. Well, if we find life on another planet, it's exactly like our DNA, that theory suffers a big blow. If it's not like our DNA, all of a sudden it becomes big. Pretty much there's no way we're not going to find alien life and not learn about the origin of life on Earth.
Good answer.
I'm interested in how the Viking program compares in scale, or compared in scale and sophistication to what's been going on for the past 20 years.
Well, the Viking mission was a engineering high watermark. It was 2 orbiters, 2 landers. Today's dollars, maybe 5 billion, maybe more. It was the most sophisticated instrumentation at the time, but of course it landed in 1976, so it was using late 60s, early 70s era instrumentation. One thing to note, though, is because of that immense expenditure, certain technologies were defined that we are still using. The Mars Science Lab, which has far more sophisticated instrumentation on board, is nevertheless using an entry, descent, and landing envelope, let's say the parachutes, the supersonic parachutes, for example, that were first proven by Viking. So we are still standing to some extent on the shoulders of that investment. In terms of the instrumentation, I'll pick one out of the Mars Science Lab. There is an X-ray diffraction instrument. I mean, this is, without going into the details, this is the gold standard of what kind of mineral you're looking at, and Viking didn't have anything that would approach that. So we've done a couple of things since Viking. One is we've moved to looking for habitable environments rather than direct detection of life. And secondly, we've learned to pace out what Viking attempted to do in a single mission in a whole decade-long program, so that one scientific discovery can build on another, and that the technologies can build on each other as well. And I think I would argue that in the end has been a more successful approach, even if it's taken a little bit longer.
Robert, you're not the only entertainer that has some ideas about what alien life looks like. Steve Allen, many years ago, directed people to look at things in their immediate surroundings, like that white piece of paper that's sitting on the desk there. If you look carefully, in every case there'll be a little black thing. If you look at the ceiling, there's a little black thing. And he believed those are the ones that got here. And those are the ones we really need to be looking for.
Yeah, let's go on. Do we have another question?
Yeah.
I'm just wondering, I know it's fallen not out of public favor, but almost out of the spotlight. Do you have any thoughts on the WOW signal? Or have there been any new thoughts lately?
Oh, on the
Wow.
WOW signal? Anyone want to address that?
I think it's considered an artifact, but I don't think we have any SETI people, any search people here.
Yeah, I mean, the WOW signal, for those of you who don't know, it was during one of there's been a great history of searches for intelligent-looking radio signals, and so the WOW signal is an example of one, and I don't remember the year off the top of my head, but it was quite a while ago. The problem with it is it wasn't...
August 15th, 1977.
There you go.
I think that's worth a wow.
Wow.
I guess
the real problem is that it wasn't repeated, and so that's what we look for. If it was, a real signal, we would be able to repeat the detection with the same instrument and with multiple instruments all over the world, and that's how the SETI detection protocol works, is that, if we hear something interesting, we want everyone else to hear it too, and so we'll spread it around to all the other telescopes. That's how you rule out some kind of spurious artifact or, someone's cell phone 3 offices over that's affecting your instrument. That's how we rule out artifacts like that. So, no, I don't think that there's been any more research that's been done on that, unfortunately.
I don't think they ever ruled it out, but as you say, reproducibility is what's important. You're not going to go to the public on something that might be important.
On the Science Channel, I've seen a number of programs that say things like, we're all Martians. And I was just wondering, Scott Hubbard, how viable is that?
Yeah, well, this is a piece of celestial mechanics. It is easier to get material from Mars to Earth than the other way around. And we have about 95 confirmed Martian meteorites. We know from the trap gases that this did come from Mars because the gas is exactly the same as the Mars environment, not Earth's. And so I have a number of colleagues, Chris McKay is one of them, who is fond of saying something to the effect that the planets have been swapping bodily fluids for some time. And if you had the right material there, maybe it took off. The Earth and the inner planets went through what was called a period of heavy bombardment, early in the formation of the solar system when life might have been formed and wiped out multiple times. Could a single meteorite seed life here? I don't know the answer to that. I'll look to my two planetary science colleagues here and say, do you think that's possible?
I'll just say, you can't rule it out. It's Mars and Earth actually look quite a bit similar then, and the possibility that life originated in Mars and was seeded to the Earth is a possibility. Mostly you apply Occam's razor. It involves more complex assumptions, so it's not what you consider your higher probability thing that occurred. One thing that's worth mentioning, though, is Venus particularly looked almost identical to Earth around the time life formed on Earth. And since we're, as Chris McKay says, swapping bodily fluids, it seems almost inevitable, I'll say, I'm not quoting anyone, so I'll take the blame if I'm wrong, but if that's too strong, that rocks from the Earth, which if you pick up now are almost always full of microbes, probably landed on Venus. So even if life couldn't have started on Venus, it seems hard to believe it couldn't have been seeded. The problem, of course, is Venus, any life there has now been so firmly wiped out that it's not even clear how you look for it. So,
and I'd just like to add on that theme, the probability if we find life on Mars or that it is related to us or to Earth life, terrestrial life in some form, that's the highest probability. My hope is it's not, because I think that would be a lot more interesting.
Yeah.
That's right, and actually as an outer solar system person, I have to, of course, bring up Europa, which is one of my favorite places. So if there's actually life on Europa today, underneath this icy layer at the top, we think this giant liquid water ocean. If there's life there, and I think Europa is a fabulous place to look for life, Europa hasn't been swap and spit with the inner solar system. It's out there pretty much on its own. So if we find life on Europa, the chances that that's a second independent origin of life, a second genesis in the solar system, are really, really high up there. So that's part of the reason why I think that we should be looking for life on Europa. Forget all this Mars stuff. not to provoke my panel or anything.
A strong advocate. Yeah, he's been waiting a while.
If it was possible to send something to Europa and melt through the ice to get down to the water, what kind of instrument would you use to see if there's life in that water? Would you use a microscope, or what kind of thing would let you know there is something swimming down there? Some microbe, I guess.
Right now we know so little about Europa that you'd send pretty much anything you can get your hands on. A microscope would be fine. A camera would be fine. I mean, we think Europa probably doesn't have multicellular life. If we're wrong about that, there could be fish there. Probably not, but, or chemicals, we'd want to sample. Pretty much, Europa is such an open book that anything you get under the ice, without contaminating it. The problem is, one thing about an ocean on Europa is whatever you send is going to have to be sterile with a capital S. That's going to be a problem. But anything there, instruments, chemical instruments, microscopes, cameras, anything would be great.
What would you send, Richard?
Well, I agree that it would be wonderful if we actually could catch something on a camera, but I would maintain that that's not the highest probability approach, and I would advocate that you would want to have chemical analyses, and again, based on what we know about life on Earth, I could do some discrimination in terms of carbon signatures. Or is there, what carbon compounds might be in the ice or in the water, and can we discriminate them in ways that we can relate back to how we know life discriminates carbon compounds on Earth?
Yeah, let me just add on that point that the three concepts that were put forward very recently for Europa mission of less cost than had been previously proposed, of the three of those, the lander carried by far the greatest risk, because it turns out that we only have 5, count them, 5 up-close pictures of Europa of enough resolution to even begin to think about where you might land. And only one of those is really high resolution enough. So before you go land there, you would really want to have a much better characterization of the surface. The payload for the proposed lander, though, was much along the lines of what Richard was saying. You'd want to have basic analysis instrumentation that would look for things like carbon compounds and other types of chemistry that could lead you to infer what might be under the ice. I think melting through the ice and having your Europa submarine is a little bit further in the future.
I want to make one follow-up comment. The difference between, when you ask this question about Mars, we pretty much kind of know what we want to send. And I think that's a testament to this systematic approach that Scott was talking about for Mars. We've done a lot of work which isn't direct life detection. We backed off trying to discover it for the end of the current administration. And now, actually, we pretty much, you start asking people what we want to send to Mars, they're going to say, well, why don't we look for this here or this here? And that's because of what we've learned about Mars by our mission so far. So it's a testament for a systematic approach that I think has been definitely paying off for NASA.
Yeah, we need to do that for outer planets, too.
Yeah, and the systematic approach that Scott just described with these 3 next missions, it's just that we're only at step 2 with Europa, and we're at step, 20 for Mars, and we've had a lot more missions.
The different scale.
Okay, let's go on. Probably have time for 2 more questions here.
From what I'm understanding, the water on Mars is in a frozen state. What's the chances that that water could be in a water form underneath the surface? Is there a chance that underneath the surface you would have the possibility of caverns where water could flow? And what's the likelihood that life could live in that kind of an environment? And to what degree do we have the technology to do anything about that or measure that at this time?
I'd love to address that one. I could talk for an hour, and I've only got a minute. So one of the most, for me, exciting discoveries of Mars exploration was what I mentioned earlier, the chemical that will poison us. It actually has a tremendous ability to lower freezing points. Anybody who's ever lived in a snowy environment, when you have ice, you put salt on it. And perchlorate has a eutectic, or where it will be liquid, at -60, -70, which are just common Mars temperatures. So I personally believe that there is liquid water at some periods on contemporary Mars. Now, your next question is whether or not that's a viable environment for life. Again, I could talk for an hour, but I can say the problem is it's very salty.
I understand alkaline environment would be good for asparagus.
And we thought we discovered it until we realized it was perchlorate.
Right. There is one, if you go on the NASA or the JPL website, there is a absolutely fascinating sequence of images that have been put into a kind of a stop motion display from the Mars Reconnaissance Orbiter, showing a place called Newton Crater over a season, the appearance and disappearance of dark streaks running down a canyon wall. And is that one of these, very, very alkaline flows coming out where a little ice plug has been melted? I mean, that's one potential explanation.
And I think it's worth mentioning to what the questioner was talking about, underneath the ice, which you guys didn't mention, there's actually a real possibility that there's water underneath, like a kilometer down or so in the crust. We found life in similar places on Earth. The reason I didn't mention it first is we're not sure how we get there to look at it.
Great. Okay, I think we have time for one last question. The lucky winner. Raise your hand high.
Aside from the fans in this room that are already sucked in, how can we make it interesting and popular, this whole hunt and all this science, for people other than the people we're used to talking to who are already here?
Robert, do you want to address that?
Well, I think talk to your friends. I mean, you probably know, for example, if you enjoy science fiction yourself, you probably know a number of science fiction fans who are not interested in real science. I would encourage them to visit the NASA website, the Planetary Society website, to get images of the current state of our exploration and see if it can generate an interest in them. Most importantly, it's aiming for young people. It's giving a 12-year-old a subscription to the Planetary Society now that they have a kids page, thanks to Bill Nye, who's a great educator and has tremendous youth appeal. So I think that I think a good thing is to look around at your nephews and younger brothers and sisters and all that, and really try to stimulate their interest at that age.
I will refer to the Kepler mission, which I think is a game changer for all of this. Kepler is finding a lot of planets. It looks like planets a lot like Earth are 0.1% or 0.5% or something like that, and we're not even sure you need to be like Earth to have life. So I could make an argument that you could go out tonight, look up in the sky, and see thousands of stars that have places that could have life on it. That doesn't give a new urgency to understanding all this. I don't know what does.
That's great. On that note, let's thank our panel, and thank you, audience, for some great questions. And just a reminder that bidding on silent auction items ends at 7:30 tonight, so head on over to the exhibit hall and take a look. Also, DVDs of this and all the sessions are available, $10 each in the lobby. Thanks, everyone.
Thank you for saying something nice about me up front. Took the pressure off. Because ultimately that is